For the next part of notes, we're going to be talking about solving inequalities, and this time we're also going to be using addition and subtraction. So to solve and graph an inequality, we're going to use the inverse operations. We are going to use the inverse operations to isolate the variable just as you would to solve an equation. So what we just did to solve equations, we're going to do the exact same thing here to solve inequalities. So the inverse operation of blank is subtraction. Well, that's addition. And then going the other way, the inverse operation of blank is addition. Well, that's subtraction. You know these. Number 4 is where it's new. So when graphing an inequality where the number is a solution, we're going to use a closed circle. So what that means is if you see a greater than or equal to, or a less than or equal to, whenever we graph these, which we're going to be using a number line, it's going to have a closed circle on the number that it is. So it's going to be a circle that is filled in. That's what you're going to see. That's what it means by closed. However, when graphing an inequality where the number is not a solution, we're going to use an open circle. And so that's whenever we would have just the greater than or just the less than, no equal to with it. And so that one is just going to be a normal circle. It's not filled in. That's what it means to be open. Okay, and then very similarly, the addition property, this time of inequality, because we're working with inequalities instead of equity. The addition property of inequality states that when we add the same number to each side of an inequality, it's going to remain true. So if we added 2 on both sides, that would work. If we added 10 on both sides, that would also work. It would still be true. So then, of course, the next one is the subtraction property of inequality. The subtraction property of inequality. And so that's the same thing, except we're talking about subtracting this time. So as long as we subtract the same number on both sides, it'll still be a true statement. So number 8, to check your inequality solution set, we're going to choose any number that is shaded in. And so we're about to see examples where you're going to be shading it in whenever we graph, so you'll know what that means. And then lastly, we will then evaluate the inequality with that number to make sure the inequality is true. Because if we then find out it's false, we know that we need to change it. Okay, so let's solve and graph the inequality, and then we're also going to check our solution. Okay, so our first one here, we have g plus 2 is less than 5. Well, we're wanting to first isolate the variable, so we want to get it by itself. Well, I can see the g plus 2 is together, so the inverse operation of addition is subtraction. So we're going to subtract 2 on both sides of the inequality. Well, 2 minus 2, that cancels out to 0. So we're left with g is less than, so remember it's not an equal sign because we're talking about inequalities now, so it has to be the exact same sign. G is less than, well, 5 minus 2 is 3. Okay, so here's our inequality. G is less than 3. Well, in this case, because we have the less than symbol, it means we are going to have an open circle whenever we graph it. So right here, we're going to come to the number 3, and we are going to have just a circle around 3. It's not filled in. It would only be filled in if we had the equal to portion underneath our inequality. Okay, and so we're saying g is less than 3. So what numbers are less than 3? Well, 2, 1, 0, -1, all the way down. So we're going to shade to the left of 3. Because any one of those numbers would work, because they're all less than. -1 1/2 would work. -4 1/2 would work. All of those will work. Okay, and then notice that I put a big arrow here at the end because it continues all the way to negative infinity, because we could plug in negative 10, negative 100, negative 1000, and those would all work. Okay, so now to check our work, we're going to choose any number on the side that we shaded in. So let's choose negative 3. We can choose any of them. And now we're going to plug it into the original statement it gave us. So I'm going to plug in negative 3 for G. So I have negative 3 plus 2. We are checking to see, is that less than 5? Well, remember with negative numbers, let's come over here to negative 3 on the number line. If I'm then adding 2, would I move left or right? I would move right 2. So that would put us at negative 1. So is negative 1 less than 5? Yes, that is a true statement. Okay, well, let's say, for instance, that you actually didn't shade it the right way. So let's say that you shaded it to the right of 3. So let's just take the number 5 and let's plug it in so you can see what happens. So I'm going to have 5 plus 2, checking to see, is that less than 5? Well, 5 plus 2, that's 7. Is 7 less than 5? Nope, it's not. And so that's how you know that you shaded it the wrong direction, if you got a statement that is false. All right, let's flip over and do some more examples. All right, number 1, we're gonna solve it and then graph it again. So remember, we're isolating x, so the opposite of subtraction is addition. So we're gonna add 1 on both sides. So now we have minus 1 plus 1 is 0, so we have x is less than or equal to, well, 5 plus 1 gives us 6. All right, so are we gonna have an open or closed circle? It is going to be closed this time, and it's because we now have that equal to portion in the inequality. Well, if I look at my number line, I don't have the number 6. Well, let's just extend it, and here would be 6 right here. And then now we know we're going to have a closed circle on the number 6. Okay, so we're saying that it can be less than or equal to 6. So what numbers are less than or equal to 6? Well, 6 works, that's why it's shaded in. Well, 5 works, 4 works, 3 works, all the way down for all these negative numbers. So we are going to shade to the left. And don't forget at the very end to put that big arrow because it keeps continuing for the rest of those negative numbers. All right, so let's check. Let's choose any number that is in the shaded section. Let's choose 3 and plug it in for x. So we have 3 minus 1. We're checking to see, is that less than or equal to 5? Well, 3 minus 1, that's 2. Is 2 less than or equal to 5? Yep, it works. So we know that we did it right. Okay, I want you to go ahead and give number 2, 3, and 4 a try. Be really careful on number 4 because there's a little trick on this one and I don't want you to fall for it. If you still want a little bit more explanation, keep watching the video and I will give detailed solutions. Otherwise, go ahead and pause the video and give it a try on your own. Okay, number 2. The opposite of addition is subtraction, so we're going to subtract 3 on both sides. Well, 3 minus 3 is 0, so they cancel. So we have x is greater than or equal to 0 minus 3 would be negative 3. Because remember, we would start at 0 and then go left 3. So it puts it at negative 3. Well, in this case, it's going to be a closed circle because we have the or equal to. So at negative 3, I'm going to have a circle that is filled in. Well, now we're saying x is greater than or equal to negative 3. So what numbers are bigger than negative 3? Well, negative 2 works, negative 1, 0, 1, all the way up. So this time we are shading to the right. And then we have that arrow at the end. Now let's choose any number to plug in and see if it works. Let's choose the number 5. So we have 5 plus 3. We're checking to see, is that greater than or equal to 0? Well, 5 plus 3 is 8. Is 8 greater than or equal to 0? Yep, So we know we shaded it in the right direction. Okay, number 3. So in order to isolate the variable, we're going to have to subtract 6 on both sides. So we know 6 minus 6 is 0, so we're left with x is less than 8 minus 6 is 2. This time we have an open circle because we do not have the equal to portion. So at 2 we have an open circle. And we're saying x is less than 2. So that means all the numbers smaller than 2. So we are shading to the left of 2. Now let's choose any one of those numbers that is shaded to plug in. We could choose -2. So let's do 6 plus, and we have -2. Check to see, is this less than 8? Okay, so let's think about if we were at the number 6 on the number line. Well, if we have that negative, it means we're moving to the left 2. This is also the same thing as 6 minus 2. So we're checking to see if that's less than 8. Well, we know 6 minus 2 is 4. And so is 4 less than 8? Yep, it is. So we know we shaded in the right direction. Okay, number 4 is the one that's a little bit tricky, and so you have to be careful. So we're isolating the variable, so we need to add 3 on both sides. So you probably got this step. So 1 plus 3, that's 4. Then we have less than, and then minus 3 plus 3 cancels out, so we're left with x. So we have 4 is less than x. Well, we could rearrange this inequality so that x is on the left-hand side. And if we did that, it would read as x is greater than 4. Because remember, the bigger n has to be with the x because that's how it originally was. So we're going to come over here to 4, and it's going to have an open circle. So we have an open circle right here. And it's saying x is greater than 4. So that means we're shading to the right. Because 5 is bigger than 4, 4.5 is bigger than 4, so on and up. However, you were probably really tempted right here to shade to the left because you saw the 4 is less than x. That is not the case. It is saying that x is always bigger than 4, so that's why we have to shade to the right. So now let's just plug in a number. So we could choose 5. So let's check. So 1, is it less than 5 minus 3? Well, 5 minus 3 is 2. And 1 is less than 2, so we know we did it correct.